Hello, Mr. Ravi.
Hi Nandan, how are you?
I'm good. How are you feeling now?
Yeah, I'm okay. I'm fine. We can go ahead. No issues at all.
Okay. Uh, just let's wait for 2-3 minutes,
Okay,
then
sure.
we can start. Huh?
Okay.
So, how's the weather right now?
Yeah, here the temperature is around 10 degrees centigrade right now.
10 degree. Okay.
Yeah.
Proper winter started, huh?
Yes. Yes, it has started. And it will come to 5 degrees in the next 4 days.
Right.
Yeah.
The background is blurred. So in north we have that smog issue has started slightly, So hopefully,
Yeah, I think every winter you have this issue in Delhi and surroundings, right?
yeah. The problem will happen mostly in January when we have to travel and the flight cancellations, and that becomes
Yeah,
slightly
right.
difficult, to plan.
Correct.
So I think we will start in. Um, we can start now, I think. So I mean, first of all, thank you so much. I understand. You had a minor surgery 2 days before, and I really appreciate helping us out. And very briefly, I'll introduce our speaker, Mr. A.R. Ravi. Uh, in one line, he's a purely seamless glove man uh, who has actually worked on the floor, starting from yarn manufacturing, yarn designing, to gloves designing, dipping lines, setting up plant. So, over 37 years of experience in the industry. His expertise spans various aspects of glove production, including design, development, operations, and market expansion. And currently serving as R&D manager, country head at Mechanics Sphere LLC. Mr. Kumar oversees product development, quality audit, and innovative solutions. His notable career includes leadership roles such as Vice President of Product Development at KLD China, where he focused on advanced manufacturing technologies, as well as Business Unit Head for Midas Safety, where he managed significant glove manufacturing projects, right from installation of machines to, development, where he managed significant product glove manufacturing projects. And like I said, whenever I am stuck, I know he's the one who helps me out, because although I am into yarn manufacturing, but he's the one who guides me for dipping, various types of dipping and all this thing. So I mean, it's completely up to you, Mr. Ravi. If you want to give some introduction, or what I can do, I can go through your PPT. You can add on your points, and then we can have discussion. We have a lot of audience, and we can take it forward like that.
Yeah, I think we have about an hour and 10 minutes or so. So let's go ahead with the PowerPoint presentation, and I will intervene wherever it is required.
Correct.
And if any of the participants have any questions, so I'm ready to answer to them.
Yeah, I really want less stress on your eyes, but at the same time, we want to learn from your experience. So today's session is, wait, let me just see. I have shared your, let me just see why it's not. Wait, just let me open your PPT. So is the PPT
Yeah, it's clear now.
visible now? Yeah. So today, mainly we are going to discuss recent developments related to HPP and Aramid. Um, Today's session is mainly on seamless gloves. Um, in future, definitely we'll look into cut and stitch. And as I said before, Mr. Robi has done a lot of work on seamless gloves, uh, from 7 gauge to 21 gauge now. So, today we'll focus more on the seamless glove. So, I think first few slides, Mr. Ravi has mentioned about how complicated is our hands. Mr. Ravi, you'd like to share something, your views on this?
Yes, the hands, both the right hand and left hand for any human being, is the most invaluable and most useful tool in daily lives. We can do a simple act like a gesturing with the hand, and a most complicated task that many women perform in several industries, and also men perform in several industries, right from nanoparticles assembly in electronics line, or heavy duty construction, or aviation, you name. There are millions of activities that every human being does on a daily basis using the hand, and hand is the most important tool that we have. And unfortunately, there is no spare part. So we have to protect those hands very carefully throughout our life. This is what I would like to say.
Yeah, I mean, as you rightly said, and I can see that demand for hand protection is growing in India. I can see there's an exponential growth. Although we are manufacturing yarn, but we also do some of the aramid glove knitting, and I can see suddenly there's an increase in hand protection. Even in smaller companies, I can see labors, they are demanding cut resistant, heat resistant gloves. And the reason is quite obvious, because even if you have a skilled or unskilled labor, and if there is an accident in hands, definitely he cannot work. He will need some assistant. So, complete more details on our hands. Different types of joints, different types of ligaments, artery, nerve. And again, this slide is also talking more about about our hands. Like 27 individual bones are divided into three main sections: wrist bones, metacarpals, and finger bones. The wrist contains 8 carpal bones. So it's very important. And like I said, although I can see that automation happening in um other side of world, but in this part of the world, I can see huge demand coming up for hand protection. And I can see many units are coming up, dipping units, glove units. In Panipat itself, I can see that over 2,000 glove knitting machines are there now, whereas 2 years before it was hardly 100 or 200. And now I can see many companies are getting into gloves knitting, and obviously future they will get into dipping. So this is the time where we should look into these things in detail. Um, Mr. Ravi, you want to add something on this, on your with your experience, because you
Yeah,
know.
no, yeah. Normally, we take it for granted what we have in life, whether it is physical things or our personal things or even our own body. We don't give enough importance to our health, our different parts of the body, and how we can lead a good and meaningful life. As part of that, because we are all employees, most of us are employees, and we do our work with our own hands, it's very important for us to protect our hands. That is the reason maybe our previous generation, our fathers, our grandfathers, our earlier generations, the value for life and the value for human hand was much, much less than what it is today. So ultimately, I mean, obviously now people are demanding health, hand protection. People are demanding safety protection in industries. So that's where the hand gloves and the hand protection makes a very important contribution in human safety in industrial life. This is what I want to mention.
Yeah, right. So basically, these gloves are mainly to you know help protection against lacerations, abrasion, cuts, bruises, damage to tendons, puncture and impact resistance, and internal injury to muscles, heat and burns, and loss of sensation. The new thing is coming up is impact cut, which I'm sure Mr. Ravi will also add something, because so far we are doing cut resistance test, but now we have ISO 13998 and 9 ISO 13999, where we are talking about impact cut, which I can see is very important, and we'll see more standards in future. Um, yes, traditional, when we talk about anti-cut or cut resistant yarns, there are different ways of manufacturing this. HPP filaments are most commonly used, twisted HPP filament or Aramid uh, ring spun yarns uh, with core in glass or steel, and a variety of things we can do, like staple fiber and filament together, or composite yarns. And next few slides, I'm sure Mr. Ravi will give us more idea about recently what's happening, where we are trying to move away from glass and steel wire. So Mr. Ravi, you want to add something to this one, or we take it to the next slide?
Yeah, see, the glove industry started somewhere in early 70s. Before that, it was all mostly fabrics, and whether it is cotton, acrylic, or different type of fabrics were used as hand protection. In late 70s, it started with cotton, then it started with acrylic, then it started with viscose. And in early 80s, it started with 7 gauge and 10 gauge type of gloves, and now it is all the way up to 21 gauge. So earlier we had very less category and very less variants of materials that go into hand protection, and there was virtually nothing to protect the human hand with in terms of cuts and lacerations. But in the last 15, 18 years and 20 years, from 2004 onwards, first DSM in Netherlands, DSM Dyneema, they developed the HPP yarn, which are used for gloves, and later on, several companies have started adopting the technology and transforming the technology and improving the technology. Now we have a plethora of materials, whether it is HPP or Aramid or steel, tungsten, carbon, then different type of other material and a composite material. And we can blend all of them to make a very good glove in right from 7 gauge to 21 gauge.
Yeah, I mean, like Mr. Ravi has mentioned that ultra high molecular weight polyethylene is not a new material. It's a very old material, but this material started being used in hand protection from last 20 or 25 years. And now, I mean, most commonly 400 denier, 300 denier, 200 deniers are being used. Now even 100 deniers are available, both in white and in color. and we can see a lot of development in this field. And most commonly, these materials are being used for seamless gloves, which are used for knitting, for hand protection. And important features, you know, reduces hand fatigue, keeps hand cool, and provides protection against laceration. Very high tensile strength. These materials are highly crystalline in nature, and uh, Mr. Ravi will explain in next few slides what are the new interesting developments happening, and which is where we can see this industry to move forward in next few years. Latest development, I would let Mr. Ravi to discuss this latest development because he has got the experience where he has not only developed the filaments but also dipping lines,
Yeah, till about 2020, the most of the yarns were only 2017-18. Most of the yarns were only 400 denier and above. After 2017-18, several companies in Japan, in Netherlands, in Germany, as well as in China, have developed HPP yarns right up to 200 denier and now even 100 denier, 100 denier also in different colors. The beauty of this is the technology has developed so very well and so sophisticated that the price is coming down, the capacity is very stable, the demand is increasing quite a lot. So you will find a lot of uniqueness in the yarns coming from different manufacturers. So now we have 200 denier with almost 1 denier per filament. We have 100 denier with 0.75 to 79 denier per filament. And as you see, you can see we have 200 denier with 242 filaments. So, and the beauty of this is the HPPE can provide a very, very good perspiration absorption and sweat release on the hand. If a worker or anybody who is working with hand gloves, he may be using it for 8 to 9 hours in a day. So unless until the glove is very good in terms of its dexterity, in terms of its fit, feel, and comfort, the individual is not going to use the glove. So that is where HPPE makes a significant contribution in terms of perspiration, evaporation, in terms of protecting against hazards that we have discussed before. So this is going to remain a mainstay in the hand gloves for probably next 10, 15 years until a new material is invented. This is what I wanted to share with the team.
And like you rightly said, to 2018, 2019, 2020, just to give you an idea, price for 200 denier HPP was $35, $42, it was very costly. And suddenly, the price came down to $24, $22, $20, and so it's not only interesting from the, you know, properties wise, but it's also very important to understand the commercial side so that the business becomes viable and we are still competitive.
I just want to add one more thing. About 7-8 years ago or 10 years ago, if you have a glove with HPP, it was costing $4 to $5 for a retail end user. Today, it is coming down much drastically as compared to what it was for 7-8 years ago. So more and more regular and non-cut applications are getting switched into cut applications. So earlier where people used to use multi-layer gloves with cotton, nylon or polyester, now they are able to use a single layer with HPPE. So the dexterity of the glove has improved, the weight of the glove is coming down, the flexibility of the glove has gone up, and also the protection has gone up significantly. Yeah. That is where the HPPE consumption in glove industry is seeing a very rapid increase in most of the manufacturing space in the world.
And the most important, what I'm seeing that these products are not only being used for human protection, but these are also being used for protection, for our pets, for horse cover, dogs cover, anti-cut cover for animals. So I guess, it's a phenomenal growth coming up. So this slide is basically just to show that ultra high molecular weight polyethylene is highly crystalline in nature, and it's used in injection molding, blow molding, extrusion. Different forms of HPP is available now in the form
Yeah,
of.
I will try to
Yeah.
explain here.
Yes,
If
please.
you
Yeah.
use the same material in injection molding, you have only a very small length of the molecular chain. If you are using in blow molding, the molecular chain length increases. If you are using in extrusion, it further increases. But you can see the exponential increase in the molecular chain of the same material with this particular process of ultra high molecular weight. This is because the gel spinning technology and the melt spinning technology that goes into converting the same polyethylene granules into yarn makes a huge difference. So the same material, but the way it is manufactured, the way it is extruded, and the way it is converted into yarn makes a big difference in its properties, in its application, and in its strength characteristics. Thank you.
Okay. Yeah, I think he has already explained this. We have regular polyethylene and high performance polyethylene. Crystallinity and orientation plays a very important role.
Yeah,
This
let's
slide,
go back to the chain because I want to highlight to the one is important aspect. If you
please.
see on the left-hand side, you have the high crystalline, high molecular weight polyethylene. On the right-hand side, you have the regular polyethylene. What it means is because of the high crystallinity, the tensile strength and consequently the ability of the yarn to improve its cut resistance for the same weight and its ability to protect the human hand for the same weight of the glove increases at least 3 to 4 times. That is a crucial difference between a regular polyethylene and a UHMwPE. Go ahead, Nandan.
Yeah. So, I mean, this slide is mainly comparing different brands of HPP available in the market. We have Dyneema, Toyobo, Honeywell. I mean, Mr. Ravi, you want to add something on this one? Because I can see variety of brands coming up, especially in India,
Yes.
and it's so confusing sometimes, you know.
Yeah, let's go to the next slide. There I have given different brands.
Yeah.
Next slide, actually. Yeah.
Yes. Yeah.
Yeah, these are all the different brands that are available. Dyneema is basically from DSM of Netherlands. Spectra is a Honeywell brand. Sunuga is a brand from China, Japan. Chinema, as you know, is from Sinopec, and there are multiple manufacturers in China. Just to let the team know that out of the total 35 to 40,000 tons of HPP manufactured in a year, more than 70% is manufactured only in China. So that is the kind of capacity they have. That is the kind of consumption we have in China. Plus, of course, it gets exported to various countries also from China. And now a lot of body armor for military, defense, police, law enforcement, and other agencies. Also, this yarn is finding a lot of application. That is where the capacity and the demand for this particular yarn is increasing quite a lot. Also, there are value-added brands like Diamond Dyneema, again coming from DSM of Netherlands. Ruby is coming from a manufacturer in China. Graphene is a manufacturer again from China. Gold Silk is a company where I was working before. And Silver Silk is also from the same company. Now there is another company which is manufacturing Metal Q. We will explain later what is Metal Q and how it differentiates as compared to other materials before. Later. So you can go back one more slide, Nandan. See, this is a very important aspect that the team has to understand. These Dyneema and Spectra fibers, whether it is Dyneema and Spectra are basically brand, it is basically UHMwP. They also absorb a lot of energy. So that is where it is being used as a bulletproof material for reinforcement in conjunction with the carbon fiber materials. So this adds a layer in many law enforcement, police, defense, military, and other applications for body armor, or it is also used in glass industries where people have to handle either wet glass or a dry glass, different type of sheets. So this kind of material provides a huge advantage because the weight to size ratio is very low. That makes it very flexible. very convenient for manufacturers to make body armor using UHMwPE.
Yeah.
So we can go to the next slide.
Yeah.
As I said before, UHMwPE has got two distinct manufacturing technologies. One is a gel spinning, second one is a melt spinning. Out of all the capacities that are created, gel spinning is the most popular, less energy intensive, and also economies of scale will work better as compared to melt spinning. Gel spinning is basically, there is a diagram which comes to the next slide, or otherwise we can send it to Nandan and Nandan will share it with the team, where you have a reactor where you will put all the ingredients, what is required in manufacturing of
I think
UHMwPE.
the slide is there. Yeah, this one. Yeah.
Yeah. So you have the different type of material that go into the silo. Then there is a high-speed mixer. Then it goes into extruder. Then it goes into a spinning. So from spinning, it comes into the yarn. So this is basically a melt spinning process. Similarly, there is also a gel spinning process. I'm not sure whether I have added the sketch. I can add it later.
No, I mean, I was really surprised and happy to see that ultra high molecular weight porcelain can be manufactured using melt spinning technology. Because,
Yes.
so far it was all gel spinning. And so you think a lot of work is being done in melt spinning right now, or it's a very old concept of making in melt spinning, or because in literature I have not seen anywhere where it says that melt spinning.
Yeah, the company that I was working between 2017 to 2020, Kanglongda in China, they have both gel spinning technology and melt spinning technology. The challenge with melt spinning technology is because of the economies of scale. So in gel spinning technology, there is an intermediate process where you convert the raw material into gel and then have multi-filament extrusion lines, convert those gel fibers into yarns. In melt spinning, you have a reactor and there is no gel stage in between. So from the reactor, you have to draw the yarn through several micro size holes and then it is converted into yarn. So the speed of the yarn manufacturing, the capacity of yarn manufacturing, and the energy used per 1 kg of manufacturing is quite high. So only where value added yarns are made and where expensive yarns are affordable for the kind of application, you use melt spinning technology. Otherwise, it is mostly gel spinning technology.
Okay. No, I mean, this brings to another very important discussion when we talk about reinforced HPP or value added HPP. So, here I'd like to mention that these fine basalt and ceramic powders are added in the HPP at the time of extrusion. And Mr. You'd like to say something, because this I think is the future. Most of the HPPs are coming in this form now.
Yes. In order to improve the cut resistance of the gloves under ANSI standards beyond A4, A5 to A9, that is from 3000 grams cut resistance to 6000 grams of cut resistance, which ranges from A5 to A9, you have to use a composite yarn. You can't use a single yarn like UHMwPE, whether it is 400, 600, or 660. You can't reach that particular cut resistance. So you have to blend this HPP yarn with other material like tungsten, steel, glass, or basalt. So in order to ensure that we are able to provide a higher cut resistance material with a single yarn, so the technologies have come up in the last 7 to 8 years where they use special machines to grind basalt. Basalt is a natural rock material. It is not available throughout the world. It is available only in few countries, and China is one of those countries where they have categorized this as a national resource material, so it is not allowed to be exported as well. So they use this basalt and crush it into very fine particles of even under 10 micron. So there are heavy duty ceramic ball mills which are used in manufacturing this basalt microparticles. And again, ceramics are also used. And they also use graphene powder. They also used glass powder. And also silica. So these are the four different materials which are pre-ground into less than 10 micron, 20 micron, and they are added into the reactor along with HPP granules and other resins and catalysts. They are added in the ratio of around 10-12%. It is all confidential. They don't reveal it exactly. Even I have limited uh, ability to convey that, although I know I cannot do it because of there are some non-disclosure agreements. So these are all used in the value-added yarns, which are now produced under 400 to 440 denier. So you can reach level A5 to A6 also using this yarn in 13 to 15 gauge liners. And this is the latest development in the last 5-7 years. And now we are able to get yarns even under 200 denier also under the same brand and same properties. So it's a very huge development and makes glove knitting much more easy and flexible.
Yeah. Would like to add something to this slide?
Yeah, these are all the how silicon is added and how different other materials are added into HPPE, and how after hot drawing how the crystallinity improves, and because of that how the strength improves. What are all the different research that has been done with respect to what should be the particle size and then how the crystallinity will change. That is what is shown in the previous slide.
No,
Yeah,
this is very
yeah, go
interesting
ahead.
for
Go ahead, Nandan.
this is very interesting even for me, because so far we are doing a lot of yarns with standard HPP and reinforced HPP also I'm trying to add. But this market, like you rightly said, this market is very much protected, and it's very difficult for us to test. you know it's very difficult for us to have a standard where we can compare each lot. So I mean, you can explain this slide, and then I will discuss with you later on how we can check the quality aspect of this reinforced HPP, which is new for us.
Yeah, here what I have tried to explain is depending upon the gauge of the knitting machine, right from 13 to 21, if you use a denier of the HPP as mentioned in the table, what is the cut level of against ANSI standard that you can get? And what is the combination of material that you need to use? If I take the fifth line, that is 15 gauge, 330 denier, you get an A3 with a gold silk or a silver silk yarn. So for A3 of say 1200 to 1500 gram cut resistance, you don't have to use glass, you don't have to use steel. Just use a 330 denier, you knit a 15 gauge liner, you get a A3 cut level. And the A3 cut level, even the R square will be at the level of 0.78 to 0.85. And you will on a 45 sample you will get not less than 1200 grams and not more than 1400 grams. So it's a very stable cut level what you can get. Similarly, if you see line 3, it is 15 gauge, 440 denier, you get an A4 glove with a diamond DSM diamond yarn or a gold silk or a ruby plus kind of an yarn. So these gloves vary, I mean, weigh less than 45 to 48 grams without a coating and about 60 grams to 65 grams with coating. So you'll get an extremely good, flexible, comfortable glove in A4 to A5 under 60 grams to 65 grams a pair. So these are all the different options that are available now with the value-added yarns that you can use in your glove knitting.
And the best part is there's no metal or glass inside. That means these gloves can be recycled in a much easier way, if I'm correct.
Yeah, most of our gloves are certified for 5 to 6 time washing without any deterioration in the performance.
Yeah, excellent. So I think when I was reading this research work where they have used carbon nanotubes, and with 2% the improvement is there, but 6% and a higher percentage the strength goes down and agglomeration is there.
Exactly.
So you can
Exactly.
explain this one, Mr. Ravi.
Yeah, this research is done by a few Chinese scientists in Tingxia University in Beijing. I happen to interact with one of those gentlemen. They don't be very willing to explain everything what they have done. But
Yeah.
what I could understand was they have developed a multi-wall nanotubes, and they were able to inject into the reactor in the ratio of from 2% to 10%. Under different percentage ratios, they have drawn samples and they have done digital spectrometer analysis and thermal graphic analysis, and they were able to find that less than 2% to 3%, the tensile strength and Young's modulus will increase. But if they go beyond 6%, then it will come down, because these multi-wall carbon nanotubes, they tend to agglomerate together. They are not dispersed uniformly throughout the composition of the polymer, and thereby you will have a huge variation in terms of its consistency in tensile strength. Up to 2 to 3%, it is very stable. So beyond 3%, it is not very stable. So there are now yarns are being developed using this. Hello.
Yeah. Yeah. Please go on. Please go on.
Yeah, these are being developed by a company which manufactures about 440 denier using these multi-wall carbon nanotubes. So they are able to gain A5 glove with a 15 gauge knitting. Still, the work is going on. It is not yet proven. Still, a lot of research is going on. So it takes another 6 months to 1 year to conclude on this.
Right. This is what you were talking about, metal Q fiber.
Yeah.
Even I'll be very much interested about this, if you can explain this one.
Yeah, metal Q fiber is a developed, is a proprietary technology by another company in China. They are a vertically integrated glove manufacturing company. They have their own yarn manufacturing. They have their own spinning facility. They have their own. They are a very, very good company. They have developed using special particles which include basalt, which include ceramics and glass. So they call this yarn as metal Q. They have from 200 denier to 600 denier, they have different yarns using metal Q. And in the next slides, you can see their 13 gauge A4, 15 gauge A5 styles they have developed. So they have even developed 18 gauge A4, several styles. 18 gauge A4 will not weigh more than 35 grams or 40 grams, including the polymer. So you have 18 gauge A4 at 40 grams per pair. So that's amazing kind of a dexterity and comfort you have on the glove. So you have 18 gauge A4 using metal Q. You have 15 gauge A5. Next slide you can see.
Yeah.
So you have a 15 gauge A5. So if you want typically without any of these, you have to go for a 13 gauge only. You can't knit on a 15 gauge without glass or steel. I mean, you have to use glass or steel. If you don't use glass or steel, you have to go for a 13 gauge. Even there, A5 is doubtful.
Yeah.
So this is another company where I had worked before. They have a patented technology which they make gold silk and silver silk. They can make up to A4 and A5 on 18 gauge. So it's a very, very good yarn, value for money, and very reliable type of a product. So this is what I wanted to share with the team as to what kind of developments are happening in the UHMwPE yarn industry in China. These are some of the products that we have developed which are being used in American industrial segment and also in Australia and in Europe. The extreme left one is a 18 gauge A9 testing 18 gauge A9 testing 6,400 grams cut resistance with 20 micron tungsten and 200 denier value added yarn.
Right.
So that glove is extremely popular in pulp and paper industry, where they are using a very heavy 200 grams glove on a pair of glove. Now this will weigh not even 60 grams. So you can understand the comfort level that in pulp and paper industry. In pulp and paper industry, they use very heavy duty knives and very heavy duty equipment where they need very high cut resistant gloves. So this proved very successful, and we are selling thousands of pairs every single month for pulp and paper industry in US. The second one is again 18 gauge A7, which covers around 5,400 grams of cut resistance, and it's pretty good. The next one is a very thin 18 gauge A4, uses only 20 micron tungsten and 100 micron value added yarn. That is very popular in glass industry. That is very popular in food industry. And this particular glove is also with completely no solvents, No, it meets all the regulations, whether it is FDA, whether it is a REACH, whether it is any other regulation throughout the world. It meets all of those regulations, and it is very popular in the US industrial market. And the last one is the same 18 gauge A4 with the ANSI level 2 impact. This
Right.
this again, yeah. So this is another value added glove that we sell in energy industry. We also sell in deep tunneling and heavy duty construction industry in the US. So I just wanted to show that not only the material we have, the kind of glove we have developed, and the industries that we are serving.
In this one, just I'm curious, how do you recycle tungsten-based yarns or gloves? Because tungsten is such a costly material, and we should do something to recycle it. you know.
Yes, you are right, but I don't have an answer for that right now. I must be
Yeah.
honest with you.
Yeah. No, I mean, even we are struggling, like, because we make some yarns with tungsten in core, and tungsten being 15,000, 16,000 rupees kg. I really feel how to recycle even our spinning waste. If
Yes,
we have some
correct.
spinning waste, how to recycle this tungsten material.
It's not easy. Correct.
So yeah, this slide is mainly about recent developments in Aramid. So far, we have seen HPP. So in Aramid, from my point of view, I will say that Mr. Ravi can add on that. We can see variety of requirement coming up for colored para-aramid. There was a time when only yellow was acceptable, that we want yellow, but now I can see green, black, blue, blending of staple fibers with aramid filaments in core, core spinning with variety of cores, from HPP in core to tungsten, metal, glass. So a lot of innovation happening in aramid side as well. And value-added yarns, like I said, from 50 denier glass up to 200 denier glass in core, and from 20 micron steel up to 70 micron steel in core. And like Mr. Ravi mentioned, basalt, I can see a lot of requirement where they want basalt in core, which is a non-glass and non-metal solution. And Mr. Ravi, you can add on this one from your experience.
Yeah, see, I just want to tell the team that UHMwPE or the HPP and Aramid are complementary to each other. So it is not that one is replacing the other. Where you need high perspiration absorption, lightweight, good cut resistance, good pliability with polyamides like nylon, polyester, and blendability with several polymers like whether it is PU, latex, nitrile, bipolymer, or neoprene. Sorry, not neoprene. So HPP is the most preferred material. But HPP has got a drawback that it is not suitable for heat resistant applications. So in all the heat resistant applications and fire retardant applications and flame retardant applications, you have to necessarily use either aramid or DuPont Kevlar or Nomex or acrylic or viscose and such other fiber. So aramid is the most preferred, most affordable and widely available material. So whatever Nandan has shared in terms of the technology that is available both in spun filaments or in spun yarn or in filament yarn with several multi-cores. These are all good material that can be used for very high heat applications, flame retardant applications, and even arc flash gloves.
Yeah.
We also have a 13 gauge and a 15 gauge arc flash level 2 compliant glove with neoprene formulation on the palm, which is extremely popular throughout US as well as in Europe. So this is complementary to the HPP. So we need both heat resistant applications as well as the cut resistant applications for human hands in industry.
Yeah, and even I might be wrong, but some companies I was talking to in US and Europe, and what the trend is going, a lot of automation is happening, and the automation first priority is hot applications. Wherever there is a heat involved, those processes are getting automated first. So the idea was maybe aramid gloves demand may, I won't say go down, but may go for special requirement, because I can see variety of automation. So Mr. Ravi, you have any opinion on that,
Yeah, wherever in industries where there is a constant exposure of high heat for a human being, those are getting automated. But there are several applications where you have short time but high heat applications, and also intermittent heat applications that are not viable on automation. That's where you also human intelligence is required apart from just handling. So in those applications, necessarily Aramid will remain. And Aramid not only for the gloves, it is also used for sleeves. It is also used for body armor. It is also used for other parts of the body protection. So Aramid has got much wider applications.
That's really true, and I'm really I was surprised, or 1 month before I got a query where client was asking for to develop a Aramid cover for robots, robotic
Yes,
arm. They wanted to
correct.
cover the robotic arm with Aramid. So I like, here you go. We now have to design Aramid gloves for robots.
Yes, yeah, correct.
So yeah, this brings this to our concluding slide. So I'll let Mr. Ravi say, share his
Yeah,
feedback on.
in the last 35 to 40 minutes, we have understood different materials and combinations of HPPE, and what is the importance of HPPE in protecting the injuries on the hand. What are the different technologies that are available for manufacturing HPPE? How HPPE helps a human hand in terms of glove protection, what are the different type of brands, what are the different values that we have added on HPPE, and what liners we can knit, what cut resistance we can get through yarns. And I have also shared some pictures of the products that we make and how can you improve your own product using these yarns. So we have given an overview. By no means this 45 minutes is enough to explain about HPPE. It can take even hours together. So I welcome any individual queries who are more interested in getting into this product line or this particular product development. Me and Nandan are always willing to help any one of you. So this is what I wanted to convey. Thank you very much for your time. We have next 15-20 minutes.
Yeah, if there's
Anybody
any
interested in
yeah.
asking any questions, they are most welcome. Nandan, you can go ahead.
No, I mean, I was just saying same thing. If there's any question, Mr. Ravi can help us. Like I mentioned before, he has got an experience from yarn to setting up of a dipping line. So phenomenal experience, you know.
Maybe we can close the slide window and keep the screen open for the individuals to ask questions.
Okay, this is, can you hear me? This is Ravi Shankar.
Yes, sir. Go on.
Yeah, before you start, Ravi Shankar, I will make a small polite suggestion.
Yeah.
You are most welcome to add your query and we'll try to answer you. But if you can take a few minutes to send send a mail to Nandan with your email ID, it will help us to keep in touch later. This is what I wanted to tell not only you, to even other members who are interested in asking questions. Go ahead,
Definitely,
please.
definitely will do it. See, I'm also a textile technologist from ITD. So I want to ask. I've seen all this temperature resistance, cut resistance, and everything. But a human hand, the grip is the most important thing for most of the applications, and the way you change the pressure, how you hold it, and things like that. So how do we ensure these gloves also able to give the kind of grips required when you're holding a glass, when you're holding a metal, or when you're holding some very slippery substance? How do you make those improvements in the gloves? I thought that is a very important aspect.
Yes. The glove consists of two parts. One is the textile or the fiber part. The second part is on the palm, which is the coating part. So we have not covered the coating part in this session. So there are multiple polymers available for managing the grip, whether it is dry, wet, oil, grease, or
Yeah.
glass, or metal. So there are several polymers available, several combination of polymers available, several textures of the coatings that are available, and several coating combinations are available. It's a completely a different area of expertise. I am familiar with that. We need to have a separate session on coatings, different material coatings, which coating is suitable for which type of application in combination of which type of textile. So we need to have a discussion on different type of coatings. And your question is very valid, very important. Without the grip, we can't do any work. So I completely respect your opinion.
Yeah, and just to add to this, see, sir, what's happening right now? Industry is looking for lighter. So to give you an idea, in 2012, 2013, when we started, we were making yarn for 7 gauge or 10 gauge glove knitting machine, you know. But now, the requirement has gone for 13 gauge, 15 gauge, 18 gauge, 21 gauge. These gloves are very light. So one side, we really want very lightweight gloves, but at the same time, a lot of development happened on the coating side. So coating on the palm side. So where you can do latex, nitrile, PU, and the coating has to be very thin. Coating should not go inside. So yes, we need to have separate session on all this coating where we can show how these liners can be coated to get better dexterity and better performance.
Yeah, just to add to Ravi Shankar's query, we have a glove which has got a double coating on the palm that can lift a 6 to 6.5 kgs of fine ground steel bar with just 3 fingers and hold it there for more than 18 to 20 seconds. That is the type of grip that we are talking about. So there are technologies available, there are coatings available. So that's a different field of application, different specialization. Thank you.
Thank you. Any other question? I think there is one question, Mr. Abhijit Mandal, sir. You want to ask your question? Is it possible to develop Aramid gloves with touchscreen operation feature? With touchscreen, Mr. Ravi, I think you can add to this.
Yeah, if it is a Aramid glove, then you can't have, if it is for a welding application or if it is for any electrical related applications, it is not advisable to use steel and you have to use glass. In such condition, there are multiple options available to make it touchscreen, either on the yarn side or on the coating side.
Right. But if we do coating, then the yarn fingertip will be hidden inside. So we'll need to do both.
Not necessary. There are coatings available which can take the pressure from the coated surface finger and activate the touchscreen compatible instrument or product or whatever.
Okay, great. Thank you. So any other question, or we can, what I will do, I will share your presentation with your permission. I will share this presentation to everyone and your email ID as well, so that, if they want, they can speak to you directly on email.
No issues. Please go ahead.
Once again, thank you so much. I know you had this, surgery 2 days before, but thank you so much for, sharing your opinion. I look forward for more sessions, maybe in 6 months' time or 3 months' time, on the tipping side.
We will give time, another 8-9 minutes are there. So we have scheduled till 7:30. So I mean,
Yeah, no problem.
So
we can,
we'll wait for any other people to ask questions. No issues.
Because I think I'm getting a lot of response. What happened? Most people were very much, wanted on Google Meet. So I think I can see a lot of messages that they are not able to, join Google Meet meeting.
Okay.
How about recycling aspect? Is it common to use recycled aramid for seamless gloves, or what's the future like? Because I can see a lot of requirement for recycled.
Yes. We are already doing in China. We are using a lot of recycled aramid.
Okay.
Yeah.
And the gloves is consistent, and there's no problem with quality. And is it 100% recycled, or is
No.
About
40%.
Okay, 40% recycled and 60% virgin.
Correct.
Okay. And do you think this 40% will go up to 60% or 70% in future? What do you think?
The recycled fiber lengths will be very short.
Yeah.
And there can be a lot of other issues on the dipping stage on that recycled fiber. So there is a limitation.
Right.
Yeah, you have a lot of hairiness and other issues coming on the glove, and that will have an impact on the product performance. So 40% is optimum right now, but we don't know if there are some binders, if there are some other agents that can help enhance the recycled fiber, it can be different. But right now, I have no knowledge beyond 40%.
Right. Okay. One more interesting question for my own understanding. Normal HPP. When we import, we can just check the strength, we can check the modulus, and we can have a peace of mind that okay, this whole lot is working fine. But what happens when we have this Ruby Plus or Silk Plus or Gold Seal? How do we know that? How to test these materials? We need to do knitting and then cut performance, or is there any simple way to test?
Yeah, there are three different ways in which you can check whether it is Ruby Plus or not. The first is microscopic analysis.
Okay.
The second is the weight per meter.
Right. Hmm.
And the third is like what you suggested, knit a glove and check the performance.
So when you said imaging, you are talking about scanning electron microscope, if I'm correct?
Yes.
We need to
Yeah.
do SCM.
Yeah. 100x microscope or scanning electron microscope. So you will find that the yarn is not simple filament, but it has got reinforcements inside.
Right. Okay.
So those reinforcement inside, you can take different samples and check it. And you can also get a test certificate from the supplier. See, it's a question of credibility for the supplier also. They don't want to
Yeah.
cheat because
Yeah.
they cannot afford to have a customer who is unhappy. So
Yeah.
they, at least I know, Metal Q, Ruby Plus, Gold Silk, Diamond, Gold Silk, and Diamond Dynama, they are very reliable.
And these companies, they have their own patents. So in future, we
Yes,
don't have any issue of legal
yes,
battle.
yes.
There's no
They have
issue,
their
right?
own patent. Correct.
Right. Okay. 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 Great. Great. So I think with this, I would like to conclude this session. And like I said, I'll forward your presentation to all participants. And if there's any question, we'll be in touch by email. And once again, thank you so much. And I look forward to seeing you sometime very soon. I'm planning
Yeah,
a trip
thank you.
and I'll
Yeah,
definitely come
thank
to
you
see you.
very much. And thanks, Nandan. Thanks to all participants. I'll try to answer your queries as far as I can, and you can reach out to me anytime. So have a good evening. Bye bye.
Thank you. Thank you.